All right, logarithms. So we're taking the inverse of exponents now. So hopefully this is, again, review, converting between exponential and logarithmic, and then evaluating with common and natural logs. All right, so let's remind ourselves, how do logs work? So if b to the x equals y, b to the x equals y if and only if x equals log base b of y. So what was the exponent that literally, let's think inverse here. What was formerly the exponent is now the answer, and what was formerly the answer is now a part of the log. So when we look at our log format, we're going to take the base raised to the answer equals the log argument. That might have a different name, I just don't remember it. Those are real informal types of words here, not the best math words, but I think you get the idea. So for example here, if 10 to the third equals 1,000, then 3 is equal to 10, or log base 10 of 1,000. So this asks the question, to what exponent do I need to raise 10 to get an answer of 1,000? The answer is 3. So I'm going to run down doing a couple of these examples. You might want to pause and try your own and then check your answers with me. I'll do the first few and then I'll just put up the answers for the other ones. Alright, so 5 to the third equals 125. So we have log base 5 of 125 equals 3. What exponent do we need to raise 5 to get an answer of 125? The answer is 3. Another one, we have log base 2 of 32 equals the exponent 5. 2 to the what equals 32? 2 to the 5th. There's your next one. And the last three. Or sorry, the last two. Okay, going backwards, I'll talk you through a couple of them. This would be 3 to the 4th equals 81. 16 to the 1/2, I could write it like that. But we also know that that's the square root. 9 to the 3rd, 6 squared, 10 squared. Pause if you need to write those down. And some of our basic log properties. Pause if you need to write these down. I'm just going to do the highlights version here. Remember that if you have an answer of 1 and an exponent, then your exponent must have been 0. If the answer is itself, so if we get a log argument that's the same as the base, the exponent must have been 1. And if we get an exponent inside of our log argument here, what do we need to raise b to get b to the y? Well, it must be y, because we kind of just asked ourselves a circular question there. So a lot of times we kind of think of it as crossing out, which isn't great, but it's kind of what we do functionally. Going the other way, if log base b of x is the exponent, basically what we're saying is, what do we need to raise, or alright, so if we kind of work our way to rewriting this as an exponent, this says log base b of what equals log base b of x. The exponent becomes the answer. So what would we need to write here to match the other side? Well, it's x, and we kind of get this cross out idea again. Okay, so let's evaluate these. 2 raised to what power gives us 8? 2 raised to the third. Sorry. Oops, evaluate. 3 raised to what power gives us square root of 3? Must be 1/2. 6 raised to the log base 6 of 11. We just went over that. We get 11 out. Alright, the common log is anything with a log base 10. This is what the log button on your calculator does. So you can evaluate, I won't walk through this, but you could evaluate all of those just by plugging it into your calculator. Hit the log button on the TI graphing calculators. It's right next to the number 7, and then just fill in what comes next. To solve equations, if we are solving for an exponent, we're going to do the inverse. Just like if I was solving for, x plus 5 equals 6, I would do the inverse, I would subtract. We're going to do the inverse of raising something to an exponent, which is taking the log. So I'm going to take the log of both sides, and if I choose the right base, and I have to choose the same base for both sides, then when I choose the correct base, this stuff all reduces down to x, and we just need to plug this into our calculator. So I'll do that real quick. We're going to hit log. Since it's base 10, we just need to do 4.6, and we get x is equal to 0.663. And that makes sense because we got smaller. 10 raised to something that gave us an answer that was smaller than 10. Alright, try this one on your own. We're going to change it to an exponential equation. So think about what the base is here, so you make a wise choice. Ooh, sorry about that. Think about what the base of that log is, so you choose a wise exponent. Make sure you use the same exponent on both sides. Alright, natural log. Natural log is a log with a base e instead of base 10. This is also on your calculator. So it's the inverse of raising e to a power. Again, when we use e a lot, it's for continuously compounding. So if you know the amount and you're looking for the time, a lot of times we'll use the natural log. Evaluating these expressions, since all of these have a base of e raised to what power gives us the square root of e? E raised to what power gives us e to the 5th? Those kind of cancel. Since the natural log has a base of e, we get 4. And then you would plug these two in your calculator. So there's the answers. Alright, so just like we did before when we changed something into exponential or log form to solve, I'll walk through this. I will do the exponent one where we need to change it into exponential, so I'm going to do the top one this time. Okay, so we have log base e of x equals 4.62. So what I'm going to do is take e, raise it to the ln of x, and then take the same thing over here. Since this is log base e in the exponent, that just reduces down to x, and then we can plug the rest of it into our calculator. Second ln, put in 4.62 as the exponent, and we get 101.49. And there's our answer. You're going to try the second one on your own. Sorry about that. You're going to try this one on your own. If you have any questions, let me know in the Google form, and make sure you get those answered in class.